Cython Plus is an experimental project extending the Cython compiler that aims to bring GIL-free multi-core concurrency to Python. So there's a lot to unpack and to look at in this one sentence. So I'll go through it step by step until at the end you'll have a better idea of what this all means. Let's start with Python. So Python is a very popular programming language, especially due to qualities like being easy to learn, to teach, to use, meaning overall it brings a high productivity. And also due to an excellent ecosystem with lots of tools and libraries. But due in part to its interpreted nature, Python can be slower and less energy efficient than languages like C, which are compiled languages. Python does make up for this with strong support for integration with C and C++. And for this reason, Python is often called a glue language. On top of that, CPython, so the official Python implementation, the most widely used one, is limited by an implementation detail called the global interpreter lock, which has the effect that concurrent execution of Python threads is throttled to a single thread at a time, because only one thread can run Python bytecode at a time. But all is not bad due to the Python C API. So I said earlier that Python is the glue language, and this is the glue. This is an API that allows Python, more specifically CPython, to integrate C and C++ code to Python, and this is how Python built-ins are written, and this is how many libraries are built, like NumPy, scikit-learn, which allows optimized execution and computations in C and C++, and integration with Python, so that this is totally transparent to the final user of the library. In fact, the generally established way to optimize Python code is to find ways to write the code such that the logic is done by built-in or library functions that do the work in C. So this goes to show that what goes towards Python performance is its link to C and C++. There is one problem with CPython, and that's the global interpreter lock. One of the reasons it still exists is because it seems very hard to remove it without breaking this Python C API. So it seems very hard to allow for faster concurrent execution of Python threads in a way that is not to the detriment of the excellent performance brought by the Python C API and in popular libraries. One step on something that looks like a better solution is Cython. Cython is a language that makes writing C extensions for Python easier. So that makes writing code that integrates C to Python easier. In fact, Cython is a superset of the Python language in which one can call C functions and declare C types and make them interact with pure Python code seamlessly. And all this works thanks to the Python C API under the hood. So Cython accelerates Python first, even pure Python, just thanks to the fact that uh, the bytecode doesn't need to be interpreted anymore. So some step of the interpretation is basically done at the compilation of the Cython code. But still, all Python code written in Cython is just a call to the Python C API to do the same thing on the hood. So this brings some speed up, but not that much. But one interesting thing is Cython offers a way to bypass the global interpreter lock by removing by releasing the GIL. But this means that all you can do while the GIL is released is use pure C or C++. So this means no access to any of the high-level programming features of the Python language. So essentially, Cython allows to release the GIL, but at the cost of writing essentially C or C++ code. And the problem with C and C++ is that it exposes the programmer to errors and issues that don't even happen in Python. So there are hard to debug low-level errors like memory management errors, freeing memory leaks, freeing an object too soon. But also there are errors related to multi-threading, so data races, which don't happen in Python thanks to the global lock. So this means writing C or C++ code has little in common with writing Python code. So this doesn't really help from the point of view of an end user aiming to scale up a program in Python through using Cython. The answer boils down to write it in C again. And so this is why we're introducing Cython Plus. So the idea of Cython Plus is to extend Cython with GIL-free abstractions that feel more like Python, that are high-level features for the language. So in particular, this includes proof of concepts for Python-compatible GIL-free objects. So objects that can be used from Python like as if they were a normal Python object, but that can also be used without the GIL in parallel without a risk. An asynchronous concurrent execution model using active objects, so inspired by the actor model. A scheduler for this computation model, inspired by Go's scheduler, and a type system for thread safety through concepts like ownership. So the overall goal is to provide a programming experience that feels closer to Python's while retaining performance and especially multi-core execution without the GIL, and still retaining safety in some respects, especially with regards to thread safety. So with Cython Plus, we essentially bring multi-core execution to Python modulo, adding some static types and interfacing with Python through our GIL-free class system. So let's check it out. In the next videos, I'll show you snippets of Cython Plus code.